So we're going to start by drawing a little triangle right here. And let's think about this triangle. This side, the slanted side, bisects the 60-degree angle, so that makes a 30-degree angle. Obviously, we have a right angle here, so that must be 60 degrees. So that's a 30, 60, 90 triangle. And as you may remember, the sides of this triangle are in the ratios 1, 2, and root 3. And so this side of 1 is the radius of the smaller circle. The slanted side of 2 is the radius of the larger circle. Of course, the area of a circle is pi r squared, Archimedes' amazing formula. The area of the smaller one is pi times 1 squared, or just pi. The area of the larger one is pi times 2 squared, or 4 pi. And the ratio of those, 4 pi divided by pi, is just 4.
All right, to begin, we'll let r equal the radius of the circle, and x will equal the length of one side of the square. So column A will be equal to 2 pi r, and column B will be equal to 4x. Now the question tells us that the area of the circle is equal to the area of the square. So the area of the circle will be pi r squared, and that will be equal to the area of the square, which is x squared. From here we'll solve for x. First we'll take the square root of both sides, and now we'll simplify the left-hand side. Now that we know x equals the square root of pi times r, we'll go to column B and replace x with root pi times r. At this point, I'd like to divide both columns by 2r. And now let's square both columns. And finally, we'll divide both columns by pi. So we're now comparing pi with 4. Well, since pi equals approximately 3.14, we can see that column B must be greater than column A, in which case our answer is B.
We need to find the area of figure ABCDE, which is this one. And it's not one of the standard shapes. So what we can do is we can find out the areas of the two triangles and add them up to get the area of the figure ABCDE. It's given that AB is 8 square root 2, and that's the same as BC. So this is also 8 square root 2. And this being right angled at B, that straight away helps us find the area of triangle ABC, which is base times height divided with 2. So this is going to be equal to 8 square root 2 times 8 square root 2 divided with 2. That's equal to 8 times 8 is 64. Square root of 2 times square root of 2 is 2 over 2. The 2 and the 2 cancel out, so this is equal to 64. So we have this area as 64. Given that BC is parallel to ED, we know that this must also be a 90 degrees because these two angles, known as same side interior angles, must add up to 180 degrees. So triangle EDC is also a right triangle. We can find its area if we know the length of ED and DC. They form the base and the height of the triangle. Now it's given that CD is equal to DE, so we know this is an isosceles right triangle, or in other words, it's a 45-45-90 triangle. And in a 45-45-90 triangle, we know that if the equal sides are x units long, the hypotenuse is going to be x times square root 2 units long. So that's EC in this triangle. To know x, we must first find the value of x square root 2. It's given that AE is 6 units long, so this is 6. Therefore, EC is AC minus 6. And to find the length of AC, we go back to triangle ABC. Now here's triangle ABC. It's a 45-45-90 triangle. This being 8 square root 2, this being 8 square root 2. The hypotenuse, as we see over here, has to be the equal side multiplied with square root 2. So this is going to be 8 square root 2 times square root 2, which is 8 times 2, which is 16. So now we know that the length of AC is 16, the length of AE is 6 given, therefore EC is 16 minus 6, which is equal to 10. And coming back to the small triangle, If x square root 2 is 10, then x is going to be equal to 10 over square root 2. So we have these lengths now. We can find the area of triangle EDC as base times the height divided with 2, or times 1/2. 1/2 times base times height. So this is going to be equal to 10 times 10 is 100 over square root of 2 times square root of 2 is 2, and 2 times 2 is 4. 100 over 4 is 25. Therefore, the area of the smaller triangle is 25 units, and the area of figure ABCDE is 64 plus 25, which is 89. Answer choice D. The area of a circular tarp is between pi over 36 and pi over 16 square yards. Which of the following could be the circumference of the tarp in inches? Right then, so we know that the area of a circle is given as pi r square, and it's given that this is greater than pi over 36 but smaller than pi over 16. So if we divide everything with pi, we get r square is between 1 over 36 and 1 over 16. And taking the square root, we have the radius of the circle lying between 1/6 and 1/4 of a yard. So this is in yards. As we need to find the circumference of the tarp in inches, let's convert this range to inches by multiplying everything with 36 inches per yard. So we have 1 over 6 times 36 is less than r is less than 1/4 times 36, and this time this is in inches. Simplifying, we get this is 6 and this is 9. So the radius of the tarp, the circular tarp, is between 6 and 9 inches. And we know the circumference is nothing but 2 pi r for a circle. So this is going to be 2 pi times the radius, 2 pi times 6, that's 12 pi, and 2 pi times 9, that's 18 pi. So the circumference of the tarp is between 12 pi and 18 pi. Now let's look at the options. We have a 14 pi that works. We have a 16 pi that works. None of the other options would work. So these could be the circumference of the tarp in inches.
Okay, so this is a tricky one. First of all, this is a length of 10, this is a length of 32, this is a length of 40. Well, let's focus just on this triangle here. We have blank, 32, 40. Both of these, of course, have a greatest common factor of 8, so let's just divide everything by 8 and see what happens. If we divide by 8, we get blank, 4, 5. Well, of course, that has to be a 3, 4, 5 triangle. Scale back up by 8, this has to be 24. So 24 is the length of CD. That rectangle inside the circle is a 10 by 24 rectangle. I'm going to say, think about it this way. Divide it in half this way, divide it in half this way. And of course, that midpoint is the center of the circle. And so think about the radius of that circle. This is 5, and this is 12. Well, that has to be a 5, 12, 13 triangle. 5, 12, 13 is one of our Pythagorean triplets, and a very good Pythagorean triplet to know. That means that the radius of the circle is 13. The area of the circle would be 169 pi, pi r squared, by Archimedes' famous formula. And so if we're saying that this is in the form of k pi, k equals 169.
So we're given this square and a circle. The square S has a side length which is pi, and S refers to the area, so the area would be side square, in this case pi square. In case of a circle, C here, the radius is pi, and we're told that C is the area. So the area is pi r square, where the radius is pi, so it's pi times pi square, which is pi cube. And they're asking you to compare these to each other, the C and S. So we know pi is about 3.14, is greater than 3. So pi cubed will be greater than pi squared. So we know immediately c is greater than s, or they've written it in this form. So we can immediately narrow down the answer choices to A, B, these, C is actually less than S, so C, D, and E are out. So it's really between these two, and they're asking you to compare it to 9. So pi is more than 3.14, so pi squared is going to be greater than 9. So we know that S would be, I should say S is greater than 9. So here our inequality becomes S is greater than 9 and C is greater than S. And if you look at the answer choices, that matches with choice B.